Welcome back, WHS Algebra 2. Today we're going to look at graphing and solving quadratic inequalities. In order to graph quadratic inequalities, you need to follow 3 steps. These are the 3 steps you need to follow. Step number 1 is to graph. Step number 2 is to test. And step number 3 is to shade. Now, step number 1, it's very important. You're going to graph using any of the previous methods that we've taught you. Since we're doing inequalities, you want to make sure if you have less than or greater than, you have a dashed parabola. But if you have less than or equal to or greater than or equal to, you have a solid parabola. That's very important when you're graphing. Step 2 is to test. You want to take a point that's inside the parabola and you want to substitute it into your quadratic inequality and see if it makes a true or false statement. Step 3, you're going to shade the region inside the parabola if step 2 is a solution, so if it's a true statement, and you want to shade outside the parabola if the point in step 2 was not a solution. So in other words, if you got a false statement. Okay? And those are the steps we're going to follow today. Here's my first example. I want to graph the inequality y is greater than x squared plus 3x minus 4. So again, you can graph this using any of the previous methods that we've taught you. I think this one I'm going to go ahead and I'm going to factor it. So I'd have y, I'm just going to pretend like it's an equals x squared plus 3x minus 4. And if I factor this thing, I need factors of negative 4 that add to 3, so I'd have x minus 1 and x plus 4. And then if I solve that, I'd get x equals 1, x equals negative 4. So my x-intercepts are going to be at 1, 4. I'm sorry, 1, negative 4. So I'd put one here and here. And then the next thing I need to find is my vertex. Now remember, in order to find the vertex, you use your axis of symmetry. And the axis of symmetry you can find by adding your 2 x-intercepts and dividing by 2. So in other words, you're finding their average. So the axis of symmetry for this one is going to be at negative 3 halves, which is negative 1.5. Which is right here, approximately. Alright, so I'm going to go ahead and show you the graph for this thing. Since you have already learned graphing, I'm just going to go ahead and graph it for you. Now remember, this is a greater than. There's no equal to there, so I'm going to have a dashed parabola. And there's my graph. And you can see, here's my x-intercept and my other x-intercept, or my roots or my solutions. Okay, so now I'm going to take a point that is inside the parabola. And the easiest point that's inside that parabola to use is probably 0, 0. So I'm going to take the point 0, 0 and I'm going to substitute it in and see if I get a true or false statement. Just substituting the 0 in for the x value and the 0 in for the y value. So over here, 0 squared is 0, 3 times 0 is 0, so I get 0 is greater than negative 4. Now, this is a true statement. 0 is greater than negative 4, so we would shade inside the parabola. And here is what my quadratic inequality will look like after it's graphed. The next example I have is an application example. Example 2 says, a manila rope used for rappelling down a cliff can safely support the weight W in pounds, provided W is less than or equal to 1,480 d squared, where d is the rope's diameter in inches. And we want to graph this inequality. So there's no B value or C value here, so I know that my vertex is at 0, 0. Okay? And there's a couple ways we could do this one. We can go ahead and stick the inequality, we can just pretend like that's an equation, and we can substitute that into our calculator and then look at our table and get some points. And I think that's what I'm going to go ahead and have you do right now. So go ahead and grab your calculator and just pretend like this is an equal and substitute the equal for the inequality there. Just pretend it'll give us the graph and we can still find the table, and we'll go from there. Okay, so I've got my graphing calculator here, and I'm going to go ahead and make a table of values that I got from my graphing calculator. I know that I have a point at 0, 0, and that makes sense to me. I also have one at 0.5 or a half and 370. And I have a value at 1, 1480, which makes sense. I also have one at 1.5, 3,330. And again, remember that if you want to change your graphing calculator's table so that you can see the same values I'm looking at, you're going to go to second window, which is your table set, and all you need to do is tell it to change by halves so that you can see these same values I have, so that you can see the 0, the half, the 1, the 1.5, and the 2. Now, it should make sense to you also that I didn't use any negative values here, because we wouldn't have any negative values when it comes to the diameter of a rope or the weight of a person. You should also be able to tell that the W, the weight of the person, is going to be your dependent variable, so that's our Y value, and the diameter of the rope, which is D, is going to be our independent variable, and so we can label our axes. Okay, and then what you want to do is just go ahead and graph these points. So I'm going to have some large Y values, so I think I'm going to count by 500s, or use a scale of 500s on the Y-axis, and I think I'm going to go by fourths on the X-axis, but I'm just going to label every half. Okay, so then I'm going to start plotting my points. So I have one at 0, 0. I have one at a half, 370. I have one at 1, 140. Oh, I'm sorry, 1,480. $1.5, 3,030. I'm going to have to see where that 3,030 would be. This would be 2,000, and this would be 3,000. So this would be 3,500. So I have a point at 1.5, 3,330, which is going to be up here. And then I have a point at 2, 5,920, which is way off my graph. And you can see that this is starting to make a curve. Okay, you can see that curve there. And then we want to pick a point that is inside what our parabola would be. Well, if you could see the rest of the parabola, it would be over here somewhere. So I'm going to pick a point in here. I think I'm going to pick a point at 2,000. Let's do that point. So let's pick this point right here, which is at 2,000. And let's substitute it in and see if we get a true or a false statement. Okay? So if I put the 1 in for the diameter, 1 squared is 1, so I'd have 2,000, and for my W is less than or equal to 1,480. And that is a false statement, so we would not shade inside the parabola, we would shade outside the parabola, which would be over here. And on this next screen, you can see that I graphed the quadratic inequality for you in purple. This is what it would look like. And again, this is the point we tested, and we got a false statement, so we shaded outside of the parabola. All right, example number 3, I'm actually going to graph a system of inequalities. And again, since you know how to graph, we've taught you several different ways to graph. I'm going to let you choose which method you use to graph these things. I want to go ahead and talk about them a little bit. Our first one, quadratic number 1, is negative, so I know it's going to open down. There's not a b value, and actually that means my b is 0, and my c is 4, so I know that this parabola opens down, and it just shifts 4 units up the y-axis. So now I know that this is going to be my vertex at 0, 4, and that parabola is going to open downward. I also know, because this is equal to, I know it's going to be a solid parabola. And if I would draw this parabola, I could test a point that would be inside it. And so let's go ahead and test a point that'll be inside that parabola. Since my vertex is up here at 0, 4, I know already that 0, 0 is going to be inside that parabola. So I'm just going to go ahead and test 0, 0 and see what happens. So I get 0 is less than or equal to the opposite of 0 squared plus 4. So 0 is less than or equal to 4. And that's a true statement. So I know that I'm going to have a dashed, I'm going to have a solid parabola. And I know that it's going to be shaded here on the inside because I got a true statement. So here is my parabola. Again, as I said, it opens down. The vertex is up here at 0, 4, and it is shaded inside the quadratic inequality. The next thing I want to do is I want to look at the second one. This one has a positive a value, so I know it's going to open up. And it does have a b that's not 0, so I know that it has a little more shifting. So a couple things I can do here. I can factor this thing. Again, just pretend like my greater than symbol is an equal. And I want to find factors of -3 that add to -2. So there's my factors. So my x's, my roots, or my zeros would be 3 and -1. So I'm going to have a x-intercept here and here. So again, I can find the vertex by finding the average of those two. And that'll give me 1. So, and I guess that's actually your axis of symmetry. I said vertex. But it is the x value of my vertex. And I can substitute that 1 back in to find the y value of my vertex. So I'm going to have 1 squared is 1, minus 2 is -1, minus 3 is -4. So my vertex should be at 1, -4. And I can go ahead and take a look at what this parabola is going to look like. Now, what did I not do there? If you said I forgot to dash it, you're absolutely right. This inequality is only greater than, so this should actually be a dashed line. And I actually did that on purpose. On my next slide, you can see that I have that dashed line. But I wanted to know where the parabola was to pick a point to test. And again, the 0's on the inside, so I'm going to test 0, 0. So I'm going to say 0 is greater than 0 squared minus 2 times 0 minus 3. So 0 squared is 0, minus 2 times 0 is 0. 0 minus 0 is 0, minus 3 is -3. Is 0 greater than -3? That is a true statement, so I would shade inside the parabola. And this is the system of inequalities graphed. You can see that the pink and green shading overlaps in this region. And so this region would contain the solutions to my quadratic system of inequalities. Okay, so there's your system. All right, so that's example 3. Let's go ahead and take a look now. Let's solve quadratics by graphing. So this time we're not just graphing, we're solving. Okay, so that means something a little bit different. What we want to do here is we want to go ahead and find our x-intercepts, or our zeros, or our roots. And there's a couple ways we could do this. We can try to factor this. However, I've already tried to factor it. It doesn't factor, so I'm going to use the quadratic formula. And this would be a chance for you guys to practice the quadratic formula again also. Remember, the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And all we're going to do is we're going to substitute our a value, our b value, and our c value into that quadratic the quadratic formula, and we're going to come up with some x values. So when I do all of those calculations, I'm going to get that x is equal to a -1 plus or minus the square root of 33 all over 4. Okay, well that looks nice and pretty, but it doesn't tell me anything about where the graph is on the grid. So what I'm going to do is I'm going to go ahead and put that in my calculator. So I'm going to take -1 plus the square root of 33, and I've got to put all of that in parentheses and then divide it by 4 and see what I get in my graphing calculator. And then the next thing I'm going to do is I'm going to take the -1 minus the square root of 33 divided by 4, and I'm going to see again what I get in my graphing calculator. When you plug these into your graphing calculator, you get that x is approximately a -1.69 and x is approximately 1.19. So those are going to be my zeros or my roots. So I'm just going to kind of approximate where those would be. And then from there I can find my vertex. You can also use the axis of symmetry, the opposite of b over 2a, to find the x value of your vertex, and then we can graph this parabola. Alright, so here I have the parabola graphed, and I went ahead and I shaded. It says greater than or equal to, but if you switch, and it says greater than or equal to 0, it says the parabola is greater than or equal to 0. So the other ones I've done have looked like this, where you have your y on the left side, which kind of makes you stop and think about that for a minute. But if you test a point, for instance 0, 0, if you substitute the 0, 0 in there, you get a false statement. So you know you're shading on the outside region rather than the inside. Okay, so let's go ahead. This point right here was -1.69, and remember that's an approximation. It's not going to be exact. And this point right here was approximately 1.19. And again, those were my zeros that I found by using the quadratic formula. So if I'm solving a quadratic inequality by graphing, what I'm looking at is I'm looking at the x-axis and where the shading is in comparison to my zeros or my roots along the x-axis. So on this particular example, my shading is on the region outside of the parabola. So the shading on the x-axis goes to the left of the -1.69, but it also goes to the right of the 1.19. So what we're going to do is we're going to write an inequality to make a statement about what I just shaded on the x-axis. So let's take a look at that. Okay, so what I'm going to do here, these are my critical points. My zeros or my roots are my critical points. So I'm going to write a statement about those. So what I have shaded here on the left is I have shaded everything that is less than or equal to a -1.69. But over here on the right, I have shaded everything that is greater than or equal to 1.19. So this is an OR statement, and this is what you would write as your solution to this quadratic inequality. What you're doing is you're describing what happens on the x-axis. Okay? So you'll probably look at another example with your teacher. Let's take a look at my next example that is solving quadratic inequalities algebraically. So this is personally my favorite method of solving quadratic inequalities because I like to do the algebra rather than the graphing, but you might have your own preference. So I'm going to start here with this inequality, and I want to solve it. Anytime you want to solve, remember you have to set it equal to 0. So the first thing I'm going to do is I'm going to subtract the 15. And I still have is greater than 0. But what I'm going to do is I'm going to go ahead and I'm just going to pretend like this is an equation rather than an inequality. So I'm going to go ahead and instead of write greater than, I'm going to put the equal to in there. And then I'm looking at this, and again, I like to solve by factoring if at all possible. And I need factors of a negative 15 that add to a negative 2, and I do know those factors. So I get x minus 5 and x plus 3. Those would be my two factors. So if I solve these, I get x equals 5 and x equals negative 3. These two values are called my critical points. And what I want to do is I want to draw a number line. So I have this line down here at the bottom. And the number line needs to include my two critical points. So I've got a 5 over here and a negative 3 over here. And somewhere in the middle, kind of closer to the negative 3, I'm going to have a 0. And what I want to do is I want to determine if this negative 3 and 5 is where my parabola would cross the x-axis. What I want to do is I want to determine if the shading would have occurred between the negative 3 and 5, or if it occurred to the left of the negative 3 and to the right of the 5. So what I'm going to do is I'm going to pick some test values. And those test values, one of them needs to be to the left of negative 3, so I'm going to use negative 4. One of them needs to be between negative 3 and 5, so I'm going to use 1, and I know my scaling is not right here, but I'm going to use 1 there. And then I need a point on the right of 5, so I'm going to use 6. And what I'm going to do is I'm going to substitute these values back into my quadratic inequality, and I'm going to look for true and false statements. Okay? And again, this negative 3 and this positive 5 are my critical points. So that's why I'm choosing the test points that I did. So the first test point I'm going to try is the negative 4. So I'm going to put negative 4 quantity squared minus 2 times negative 4. And I want to see if that's greater than 15. So that's going to be 16 plus 15. Oops, sorry, that's not 15. That would be 16 plus 8. And that's definitely going to be greater than 15. So over here, I got a true statement. Okay, then I want to go ahead and I want to test my test point here between the negative 3 and 5, and that's 1. So I'm going to substitute the 1 in there. So I've got 1 squared minus 2 times 1, and I want to know if that's greater than 15. So 1 squared is 1, minus 2 times 1 is 2. That gives me a negative 1. Negative 1 is not greater than 15, so I get a false statement in the middle. So I get a false statement in between, which is very important. And then the last thing we want to do is we want to test our third point, which is this 6. So I've got 6 squared minus 2 times 6, and I want to know if that's greater than 15. So it'll give me 36 minus 12, and 36 minus 12 is 24, and 24 is greater than 15, so I get a true statement over here as well. Now, where I get my true statements, that's going to tell me where the shading would have occurred on the parabola if I had graphed this whole thing. So my shading would have been to the left of negative 3, to the right of positive 5. So again, I want to write a statement about my outcomes here. Oh, one more thing before we write that statement. Notice up here that this inequality symbol is greater than, so that's why I have hollow or open points here. Okay? And I didn't say anything about that, but I did just circle those rather than fill them in. Again, this inequality symbol is greater than, so you want the open points on your critical points. We do want to write our statement about what we've found when we solved. And so I'm going to write x is less than negative 3, or x is greater than 5. And this would be the solution to this quadratic inequality when it's solved algebraically. Okay? All right, so I've given you a lot of information today. I have some problems for you to try. please try to have these completed when you see your teacher next, and pay attention to the instructions because they each have a different set of instructions. Number 1 says to graph the inequality. Number 2 says to graph the system. Number 3, you're going to solve by graphing. And number 4, you're going to solve algebraically. So I've given you an example of each of those. I hope you can complete the rest. And here's our credits for our author. And I'll see you back in class. Hope you guys have a totally awesome night.